Hello, Mikhail. How are you?
Hello, I'm quite well, and I'm happy to welcome you on our conference, and I hope that everything is fine in your study in the Netherlands, and we are expecting for your talk already. So, how are you doing?
Awesome. I'm doing great. I'm really looking forward to this workshop. So, and yeah, everything's fine over here in the Netherlands. So, it's cold, but if I've learned one thing about Russia is never complain about cold to people from Russia, because yeah, it's sunny, sort of, bit of rain, but yeah, other than that, everything's fine. How about you?
Yeah, in contrast to Netherlands, in St. Petersburg today is sunny, a nice autumn day, and it's really great to walk. But shall we start with our technical stuff? Because I hope we all like this.
So do I. Yeah, sure. So yeah, again, welcome everybody to this workshop on improving your integration testing efforts with consumer-driven contract testing. As Michael already told you, I'm Bas Dijkstra. I'm from the Netherlands. I am the director of International Academy at a software testing services provider based in South Africa. And I'm responsible there for providing training and education opportunities for software testers, both within Inspire testing, but also to the wider world. Let's dive into what we are going to talk about today. So what I'm going to do first, so before we move on here, is I'm going to give you a brief introduction into the concept of consumer-driven contract testing. That'll take, I think, about 20 minutes, something like that, to give you a bit of background and an understanding of what contract testing is, what it is not, and how it works, generally, how the process of contract testing works, and where and where not you can use consumer-driven contract testing. After that, we'll move to the fun stuff, as I say, to the code, to actually seeing things moving and testing. And that's where you come in as well. So if all went well, you've seen in the description of my workshop a document with some preparation instructions. For those of you who want to join the workshop and work on a couple of small exercises yourself, that's why I provided the preparation document, the preparation instructions. If I didn't get any questions about that document, that could mean one of two things. One, everything was perfect and everything was well, or two, nobody read it. I don't know which one it is, and it doesn't really matter. But because I'm working with an existing code base, so I can't just code up a consumer-driven contract testing demo from scratch within 2 hours and explain everything to you. But that's okay. So throughout this workshop, there'll be some small exercises. I'll give you about 5 minutes for each of them to practice a little bit for yourself, to have a play around with the code, with the tooling that I'll introduce to you. But after that, I'll show you the solution to the exercise on screen. So even if you miss the instructions and you fail to do the preparations, that's okay. That's no problem at all. You still see and learn everything I would like to present you before the end of this workshop. To give you a little bit of background about consumer-driven contract testing. This is what applications looked like until not too long ago. Monoliths basically a lot of applications were monoliths, where the graphical user interface, data access layers, business logic layers, all kinds of different components were really tightly coupled, tightly interwoven. Maybe the database was separate, but all of the other components were not really well designed, not really loosely coupled. And to write proper integration and end-to-end tests for this kind of applications meant you had to basically test the entire application as a single component. So end-to-end tests in monolithic applications were basically always driven through the graphical user interface, even if you didn't really need it. And that made these tests hard to write, hard to maintain. Deploying new versions of applications took days or even weeks. In recent years, we've seen a shift from monolithic applications to applications that are built out of loosely coupled components or microservices, where each component is basically an application on its own. That is a component on its own and that runs standalone, that can be deployed standalone, and that communicates with other components through standardized protocols and standardized messages. And often that communication goes via REST APIs. So I won't dive too deeply into the benefits of these kind of architectures. There are people out there who can tell that much better than I do. But it is these microservices architectures where the type of testing that you're going to see and that you're going to perform today really shines. Because when we have applications that are built out of all these individually developed and deployed components, and maybe developed in different teams, different departments, maybe even different organizations, getting them all together and creating these end-to-end tests actually becomes a lot harder, because you don't need one application as you would when you had a monolithic application. You need all these different kinds of components to be deployed and to be in the right state at a specific point in time. And the big question with large-scale integration and end-to-end testing is all these individual components, all these microservices that make up the application, are they able to communicate with one another at any given point in time? So you've got dozens or maybe hundreds of different microservices developed in different teams, maybe in different departments, different organizations. But still, if you want to do a large-scale integration test or an end-to-end test, you need all of these components to be able to communicate with one another. And because each component may have a different release cycle, because again, they're developed in different teams, it's much harder to coordinate these kinds of tests. If you do it in the traditional way. So what I mean with the traditional way of integration and end-to-end testing, that focuses on the integration of everything at once. So in order to perform an integration or an end-to-end test, you need all of these components to be available and in the right state at a single point in time, being the time when you want to run that end-to-end test. And that's difficult because that requires a lot of coordination. And you have to wait until every component and every team is ready to deploy, and then hopefully they don't have any bugs in their specific components, and only then can you do testing. And the more distributed your application becomes, the more difficult this gets, the more coordination, the more overhead you get, and basically your end-to-end testing process slows down enormously. And that's exactly the problem that techniques like contract testing, and in our case, what we're going to look at is consumer-driven contract testing, is trying to address. Because contract-based integration and end-to-end testing, it does not focus on the integration of everything at once. It focuses on the integration of individual pairs of consumers and providers. Now, for those of you who are new to these terms, a consumer and a provider that's typical terminology, jargon from in the API world. So, and where the consumer is the party or the component that issues the request. For example, a request for data or for information, and the provider is the party that sends the response back with the data or with the result of some sort of operation that the consumer requested. And because contract testing focuses on the integration of individual consumer and provider pairs, you don't need to have all of these different components, all of these different microservices in place at the same time anymore. And that is an approach that scales a lot better, and that's much easier to manage than this traditional integration and end-to-end testing approach. So the way I like to summarize this is traditional integration and end-to-end testing is synchronous. Again, all of the components, all of the services have to be available and in the right state all at the same time. So that's a synchronous process. But contract-based testing is asynchronous. We'll see that in a bit if we dive a little deeper into how the process of consumer-driven contract testing actually works. You'll see that not only does contract testing focus on the communication, the integration between a single consumer and a single provider, even that single consumer and that single provider do not need to carry out their part of the integration testing at the same time. So, because we've got these contracts, so the consumer can do their part of the process, their due diligence in as part of their build and release cycle, and the provider can do the same. The only requirement you've got is at some point before deployment, everybody has to have done their part of the job, so to say. But you don't need to have all of these different components in place at the same time anymore. The way consumer-driven these contracts work are basically a contract between a contract is an agreement between a single consumer and a single provider. And please keep in mind that a reasonably large microservices-based application or architecture can have dozens, if not hundreds, of these consumers and providers. And one provider can be consumed by many different consumers, and consumers can consume many different the data provided by the services provided by many different providers. The way contract testing works is and especially consumer-driven contract testing, which is the approach the more popular approach in contract testing, and also the approach that we're going to look at in this workshop, is the consumer defines their expectations about how a provider behaves in contracts. And how a provider behaves can mean which endpoints does the provider expose? What input do these endpoints expect? So what data, what does the request need to look like? And arguably from the consumer endpoint, the final one is the most important one. What does the response look like? What output can I expect in return? How do I expect the provider to behave in a given situation? How consumer-driven contract testing works, or CDCT. So if you see CDCT, the abbreviation, that refers to consumer-driven contract testing. So it's not continuous delivery, continuous testing, something like that. It's consumer-driven contract testing. The way consumer-driven contract testing works is it formalizes these expectations in contracts. And there are tools available, and we're going to look at one of the most popular of these tools in this workshop. These tools can help you to automatically check that these expectations are met. So the tooling allows the provider to automatically generate contracts based on the expectations that you define in code. And that contract can then be distributed, can be given to a provider, and the provider can use that contract to verify that it can meet all of the expectations that are set, that are written down in that contract by an individual consumer. And because these things, these expectations are written down in a contract, the consumer and the provider can each do their part of the contract testing process at any time they want, really. It doesn't have to be a synchronous process anymore. One of the big benefits for the provider parties here is that they can develop and refactor without fear, really, without fear of breaking anything down the line, so to say. So what contract testing helps you, it helps you create trust and create confidence. That's the word I was looking for. Confidence on the provider side, that no matter what you do on the provider side, and maybe you want to use new frameworks, new technology stack, completely rewrite your component implementation, that's okay, as long as you can show, as long as you can demonstrate that you can still meet the expectations that are in those contracts. And because those contracts contain the expectations that the consumers, so the applications, the components that rely on your functionality, your behavior, that they can still that they keep working. So it's a safety net for providers. And of course, it generates a lot of trust on the consumer side, because you don't need to really care all that much anymore about what the provider parties do in terms of development and refactoring, as long as they can demonstrate, they can show you that they can fulfill all of your expectations that are written down in those contracts. You don't really need to care what they do anymore. So because you can see, well, provider A or B is able to fulfill the expectations that are written down in this contract for him. So everything is okay. As long as all of my expectations are met, everything is okay. So the way Pact works, and Pact is the consumer-driven contract testing tool that we'll use in this workshop is, again, of course, it works by means of contracts. Because it's consumer-driven contract testing, it is the consumer that actually generates the contract. And what Pact is able to do is, from these expectations that are written down in that contract, it generates mock providers that behave exactly like the behavior that's defined in the contract, which the consumer can then use to test its own implementation against. So it generates a mock provider, so an in-memory mock version of the provider behavior that the consumer can use to test its own implementation against. And for the provider end, so for the provider, from that same contract, again, that same, call it a single source of truth, really, it can generate a mock consumer. So a mock client, a mock consumer, again, a mock party sending requests. And the provider can use that to demonstrate that the responses it generates, it returns in response to the requests sent by those mock consumers, are compatible with the expectations that are written down in that contract. So that's about what consumer-driven contract testing does. There's also a lot of things that consumer-driven contract testing does not do. It's not meant to test the internal logic of a service. And by that, I mean you should not use consumer-driven contract testing to test if the implementation of a certain provider is correct. That's what functional tests on the provider side are for. So it's not meant to test all of the business logic and all of the different types of situations that a provider should be able to handle. That's really the responsibility of the team developing the provider side of the equation, the provider component. What it does verify, consumer-driven contract testing, is whether a given consumer and a given provider, again, a contract is an agreement between a single consumer and a single provider. With consumer-driven contract testing, you can ensure that a consumer and a provider meet the expectations that are written down in a specific contract. So that consumer A and provider B are able to communicate with one another. That's what you verify with consumer-driven contract testing, not if provider A is implemented in the way it should be. And again, an agreement between or a contract is an agreement between a single consumer and a single provider. So it's not, it replaces end-to-end testing, but it's not an end-to-end testing per se. So it's, again, communication. A contract is communication between a single consumer and a single provider. So if a provider is consumed by, say, 4 different consumer applications. So there are 4 different components that all rely on a single provider for data, for example, or for processing of something. That means that the provider will have to verify that it can meet the expectations of 4 different, written down in 4 different contracts, because it receives a contract from each individual consumer, and assuming that all of these consumers are implementing consumer-driven contract testing. If they don't, that's an entirely different discussion. So as I said, let's have a look at some of the tools that support consumer-driven contract testing. I want to highlight two of them, really. The first one is Pact. And Pact is very rapidly becoming the de facto standard when it comes to consumer-driven contract testing tools. And probably one of the biggest reasons for that is A, it's open source. B, it has a fantastic community. More about that in a bit. And it's available for quite a large number of different programming languages. So you see a couple of them here on screen. And I'm going to use the Java bindings in this workshop. But that doesn't mean that all of your components have to be written in Java, because Pact uses a standardized contract format, and that's standardized across all of these different bindings. That makes sense. As long as they're using Pact, you can send a contract generated by a consumer, written, implemented in Java, to, for example, a provider written in C# or in Go or in Python, and they'll be able to verify that contract because the contract format, it's as we'll see in a bit, it's a JSON document, and that's independent of the bindings of the programming language that's used to generate that contract. That said, Pact has a fantastic community. It's open source, so totally free to use, and they're very much open to contributions from the community. I could give you lists and lists of resources on Pact and the community, but I'll just give you the starting point here, which is the Pact documentation, which is, if you'd ask me, is quite good. You can find that at docs.pact.io. The only real competitor I know of in the area of consumer-driven contract testing tools is Spring Cloud Contract. And as you have probably guessed from the name, Spring Cloud Contract is closely tied to the Java Spring Boot framework. So I don't really have that much experience with Spring Cloud Contract. I'm sure it's a great tool, really, because I have no reason to assume it's not. And I've seen it mentioned quite a few times. For me, one of the drawbacks is that it only really works with components, with services that are built using Spring Boot. So using the Spring framework. Whereas Pact can be used in a much more heterogeneous environment. So with services that are maybe developed different technology stacks, different programming languages. So that to me makes Pact a lot more versatile. But that's not to say that Spring Cloud Contract is not a good tool. It's just its application opportunities is limited to services built using Spring. And that's also the reason why I wanted to show you why the rest of this workshop, so the practical part of this workshop, is based on Pact, on the Pact framework. So before we dive into the code, let me quickly go over how does Pact work again. And so once more, it's a consumer-driven contract testing tool. So the consumer is the party that generates the contract. They are in charge of writing down the expectations about how the provider should behave in the contract. It does that through running unit tests, which for developers may be good news, maybe bad news, but you'll have to write unit tests if you want to use Pact effectively. What these unit tests actually do in terms of verifying the implementation of the consumer itself, that's up to you, but you'll at least have to have a working set of unit tests to be able to use Pact, because at the moment the unit tests for the consumer are executed, that's the moment where the contract is actually generated. So again, these unit tests, these can be used to check the implementation of the consumer. So they check that the expected response can be processed internally. But much more, or at least more important, at least in this context, is that's the moment when this contract is generated. Those contracts, again, these are JSON documents. They are then distributed to the relevant provider, and the provider can pick these up and verify whether or not it can fulfill all of the expectations that are written down in that contract. So the provider can parse a contract, read all of the expectations that are in there, and check using, again, tests on their end, if its own implementation, its current implementation, is able to meet all of those expectations that are written down by the consumer. This generates, obviously, verification results. Basically, yes, I'm able to fulfill all of the expectations, or no, I've got a problem with this specific expectation because my current implementation cannot fulfill that expectation. And so either life goes on if the provider is able to meet the expectations for all of the consumers, again, in all of the contracts, or a discussion is started. And why do I say a discussion is started? Because the provider failing to meet one of more of the expectations does not necessarily mean that it's the provider who should take action. It just means that the provider is unable to meet an expectation, at least one expectation by at least one consumer. Maybe more, but at least one. But because a provider can be consumed by more than one consumer, maybe these consumers have defined conflicting expectations. So, for example, if consumer A expects a return message, a response message with, for example, a house number field that's actually that's an integer, but another consumer expects that same house number in the response to be a string, because maybe they want to allow for extensions. And that's a conflict because the provider can't return both strings and integers. It does one or the other. And maybe maybe it's but then these are different endpoints. But there you have a conflict. So what contract testing does, and that's what we'll see in the exercises as well, it highlights conflict points. That doesn't mean that the provider necessarily is at fault and has to change their implementation. Sometimes it does, but And sometimes you need it opens up the discussion with the consumer. Say, well, yeah, you expect a house number to be a string, but all of my other consumers expect that house number to be an integer. So that's why I'm providing an integer. And then that opens up a discussion at least. But unless you do that integration testing, which contract testing provides, these kinds of inconsistencies, these mismatches in expectations, are really hard to detect in even in traditional large-scale integration and end-to-end testing. But this is exactly the kind of defects that consumer-driven contract testing can bring to light. Wow, that's a lot of talking from my part. It is time to look at the code. That also means it is almost time for you to start to get to work. But before I'll leave you to a couple of small exercises, what I'm going to do first is explain the code to you. So in the preparation instructions, what I've basically asked you to do to install is 3 different things. 4 different things. A Java development kit, because we need to write and compile and run Java code, so we need a JDK. An IDE. Again, I use IntelliJ. I don't really care what you use. If you want to use VS Code or Eclipse or Notepad++ or Vim or whatever, that's okay too. I don't really care. I like IntelliJ, that's why I use it. The third one is Maven, and that's in this case a pretty important one, because that's the vehicle that enables us to run our tests really efficiently, just by giving a single command line command, Maven clean test. We run all of our tests, both on the consumer and the provider side. So I don't have to fiddle with all of these different classes that contain my tests in my IDE, really. And the fourth one is the GitHub project that I've specified. So, and let me explain the contents of that project to you briefly. It's a composite project, so meaning there are 3 sub-projects in this introduction to contract testing project. There are 2 different consumers, and what I've tried to model is think of a web shop, for example. A web shop built on using a microservices-based architecture. And I've included, of course, that web shop could have dozens or hundreds of different kinds of components, but that would be a lot of unnecessary code. So I've limited it to 3. I have a customer API, a customer component. That's a consumer here. Think of this as an API that's responsible for customer data. So a customer can have as a name, maybe a profile photo. And one of the important things is an address. So a customer can have a delivery address associated, 1 or more even delivery addresses associated with them. So that's the consumer or the customer party. Sorry. The second one is the order component, and that's the component in our application that's that manages everything related to orders. Because if you have a web shop, you'll hopefully also have orders to pick and to process and to ship and to invoice and so on. And an order, apart from which products you send, what the prices are, they also need an address because they need a delivery address. So the customers need address for invoicing, so a billing address. And the order component also needs addresses for shipping. So these are two different components, two different consumers that both consume this address API. And basically what the address API does is it manages addresses. And an address can be a billing address, it can be a delivery address. And basically an address has a number of different fields. So an address has a unique ID that uniquely identifies the address in a system. It has an address type, so either billing or delivery. A street, which is a string. A number, a house number, which is an integer in our case. The city, which is also a string. A zip code, which is an integer. So I'm not really up to date with the zip code system in Russia, but I've modeled this according to the zip code system in the US, and that's all integers. There's a state or province or whatever you want to call it, and a country. So these elements, they make up an address, really. All of the rest of the code is implementation of the provider and not that important for the concept that I'm trying to explain. It is required, though, because I want the provider to actually work and return responses and do that in a well-designed way. So that's why you'll see all of these other classes here, but you can forget those for now, at least. So that's what an address looks like. Both the customer and the order have, of course, their own implementation. The client, a client which retrieves addresses, which the component that invokes the address API, so this address provider, and processes it. I don't want to go into too much detail about the implementation of the consumer parties either. What's important here is the tests, because that's where the contract testing magic happens. So the way Pact works is, again, you define expectations about the way a provider behaves in a specific situation in code. So, and one specific path or one specific situation is called a pact. And a pact will translate once we are running these tests, it relates to a segment in the contract. So here I'm generating a pact when for the situation where I do an HTTP GET, so I retrieve an address, and the address ID exists. So what I expect in this case, in this situation, is I send an HTTP GET, and as a path parameter, I pass an address ID that exists, that points to an existing address. What I expect in that case is a response body which looks like this. So it should start with a UUID. And again, that's this UUID in the response. It should have a string called address type. That's the address type field. Another string for the street, an integer for the number, a string for the city, an integer for the zip code, and a strings again for the state and the country. Now, it's important to realize, to mention here, that these are matcher methods in PAC terminology. What they express is how you should read them, really, is, let's take, for example, this one, is in the response, I'm expecting a field called address type, and its type should be a string. The type of its value should be a string. I'm not defining here explicitly what that value should be. All I want to make sure, all I want to write in the contract here is I'm expecting a field address type in the response in this situation, and its value should be a string because that's what I need to process it. I'm not specifying here what that value should be because, again, that's internal logic for the provider, and that's something that the provider should test, really, if the right address type value is returned. It is possible to express this in PACT. So it is possible to say in PACT, I need a field called address type of type string, and its value should be this. You'll have a string, I think it's called the string value matcher. Yeah, that's the string value matcher. In that way, you can also explicitly define the value it should have, but that creates a lot of tight coupling between the consumer and the provider, and that's exactly what we do not want, at least not in these kinds of tests. That's really the responsibility of the provider. A little further down, what I'm saying here is, given I'm describing the state to the provider, so I'm saying here, the customer party performs an HTTP GET where the address ID matches an existing address, so I am expecting data. When I send the request for address data with HTTP GET, what I'm expecting in the response is an HTTP status code of 200, which signals success, and a body that is, so that's this one, and a body definition that matches the expectations that I've written down here. I have similar pacts for, and these are just for the HTTP GET. I've got some for an HTTP delete here as well. They're pretty much the same, just a little bit simpler, because with delete, there's not a lot of data that you send. The other situations that I describe here are what happens if I send, for example, this, again, an address ID is a UUID, and I'm assuming this one does not exist. In that case, so in case I send an address ID that is correctly formatted but does not exist, I'm expecting a 404. I don't say anything about the body anymore because I don't have any expectations about the data that's being returned. Actually, I expect no data to be returned. And in case I send an incorrectly formatted address ID, so for example, this is not a UUID, this is not a valid, that's not a UUID, I expect an HTTP 400. So these are the three different situations that I've identified here. Here are my actual unit tests for the customer consumer. So for the HTTP GET, there are 3. I've got an additional 2 for the delete. Here I'm using these facts, these expectations that I've defined here, and by means of their method name. So this method name you see here, packed for get existing address ID, is used here at this fragment. So this test successful. When this test is successful, it writes this part of the expectations to the contract. So what this test does is it tests for a get with an existing address ID, and it should yield the expected address data. So I'm doing some assertions here that I can actually parse the expected response, again generated by pact, and this will both check that the consumer implementation is okay, and that make sure that this part of the expectations is written to the contract. And the same for these non-existent address ID and the incorrectly formatted address ID. So for HTTP 404 and the HTTP 400. It's just the tests look a little different because I'm actually asserting on exceptions instead of parsing a valid response. So those are the tests on the consumer side. I've done the same for the order consumer. Even more so, if you look at the order tests, they're exactly the same tests. So the expectations defined by the order consumers are exactly the same, because that's a good starting point for our contract testing discussion. So what I'm going to do now is run the tests and generate the contract. So just to make sure that I'm not fooling you by showing you something that's pre-generated, I'm running the tests on the consumer side here first by using the mvn clean test command, Maven clean test, which rebuilds the project and runs the tests in this project. So that takes a little while, but it should show that there are 5 passing tests. Takes a little while. There you go. So my unit tests for the customer consumer have passed, all 5 of them. So 3 for the HTTP GET and 2 for the delete. And if I look again here now in the output that pact generates, and it generates that by default in a pact subfolder in my target folder, is a brand new JSON file, which is actually the contract generated by the consumer and targeted at the address provider. So this contract, again, it's a JSON file. It identifies the consumer. It's the customer consumer, because again, a contract is an agreement between a single consumer and a single provider. And it contains a number of interactions, and each interaction is one fragment of the corresponds to one fragment that we've defined in a test. So if you collapse these interactions, you'll see that there are 5 of them, 3 for the HTTP GET and 2 for the delete. So for example, this one is the first one here is the order in which they appear is totally irrelevant. This is one for the situation where the address ID does not match an existing address. So if this request is received, I expect the response to have HTTP status 404, which is exactly what we...
Sorry for the interruption,
Yes.
Bas. We have 5 more minutes, almost 4, till the end of this part of our workshop. And we have some time to wrap up. We have some discussion in our chat. And after 30 minutes break, we can continue. And sorry.
No worries. Thank you. That's exactly what I asked you to do, Misha.
Yeah.
So that's perfectly timed, by the way, and that's purely coincidental. That's not what I targeted. But what I'm going to do is I'm going to wrap up the explanation here, and after the break, we can get to the exercises.
Sure, sounds
excellent.
Good. Yep.
Yes, perfect, actually. This is the interesting one. So the third one, where the address ID matches an existing address. You'll see when I do a get to, here's just an example of what I think is a valid address ID. The response body looks something like this. This is what we defined in our as possible values. And these are just values used by Pact to populate the mocks, really. So the actual provider might return different values, and that's okay, as long as they conform to the expectations we've read. So as long as the address type is a string, it's okay in this case. So, and you'll see that in the matching rules. So for example, the address type is, it should match the type that is given in the example here. So the example says billing, but if the actual address provider implementation returns delivery or banana or Heisenbug or whatever, that's okay, as long as the value is a string. Let me do the same for the order. I'm going to run the tests there too. It always takes a little longer than you expect in real life. Yeah, also 5 tests as usual. Oops, no, I don't want that. Target, and here too is a contract, but this one is for the order consumer and again the address provider. Let me now distribute these to, so give these to the provider. I'm going to do this by hand right now. There is a much more efficient way. I'll tell you a little bit about that at the end of this workshop. But for now, I am going to just paste those here and overwrite the existing one. I'm going to do the same for the contract generated by the customer consumer. So what I've now given to the address provider is new contracts, expectations from the customer component as well as from the order component about how the address provider should behave. And this address provider has tests in itself. If you see Spring Boot here, it's because the API implementation is written in Spring. It has nothing to do with Spring Cloud Contract. I am using Pact here. I'm telling here this provider identifies itself as address provider, and it looks for contracts in this folder. That's this folder here. That's why I copied them here. And if I go to run the tests on the provider end, so that runs these 10 different tests. So I have one test, one verification for each of the paths that are in the in the contracts, really. So there is a little bit of, there still needs to be some coupling between of state between the consumer and the provider. That's really not something that you can avoid. But
so sounds like we run out of time for this part, and yeah, let's have a short break. Drink some, I don't know, maybe it's too late for coffee, but maybe Irish coffee, I don't know.
Not for me, not yet.
Okay, and we will come back soon in 30 minutes.
Okay, thank you. See you soon.
See you.